We're going to use these now. So find these in the middle, find a marker, find an eraser. Okay. When we get done with this, I might let people go ahead and do it now. Okay, everybody has a marker and eraser, right? Hey, I can talk. Okay. Here's the thing. Oftentimes in math, you're given a formula, and everyone thinks, yay, I know the formula, I can use the formula. Great. But what if you don't have the formula, and you've forgotten the formula? If you know where it comes from, you never need it. So instead of just relying on the formula, we're going to see where the formula comes from, so you don't actually need it if you forget it. Okay? The first one you see on 3 is the midpoint formula. At the end, I will write up what the midpoint formula is. But first, we're going to do number 1 on our boards here. So go ahead and plot A and B on your board. Oh, I did the wrong one. And after you plot your point, write your number, your coordinate point numbers right beside it so that you have that and you don't have to keep going back and forth from your paper. All right, we good? Okay, to the best of your ability, draw a line from A to B. Woo, okay. Mine's kind of straight. Got it? Okay, we're going to guesstimate now. Where do we think the middle of this line is? So I think it's right there. I think it's right there. If this line were straight on the coordinate plane and not slanted, it'd be very easy to just count how long it is, but it's not a straight line. So how do we figure out if this is correct? I'm saying that I think the midpoint, which I'll name M, is at 1, 4. What does midpoint mean? Middle. So if I added x and x and divided by 2, that would be the middle, right? So if I do my x values, -5 plus 7, and divide that by 2, what am I going to get? 2 divided by 2. Hey, there we go. Whoa. And then if I do my y value, 5 plus 3 divided by 2, what do I get? 4. We're so smart. Hey, that's the formula. You just figured it out. Formula. Midpoint is always x1 plus x2 divided by 2, y1 plus y2 divided by 2. But because we just saw it visually, it helps us not forget it. All right. We're going to skip 2. I'm going to make 2 one of your homeworks. No, actually we're not. I'm going to make 3 your homework because every time I do fractions, people are like, no! So we got to get better at those. So 3 is a homework one. We're going to do 2 together. Let's do 2. So erase. Erase. Let's do 2. -2, -8. And if you turn it vertically this time, you'll have more space like this instead of horizontally. If you turn it vertically, I still don't think we'll be able to go to 12, but we're going to do our best. -2, -8. Can we make it? All right, awesome. I'm very excited about that. And then -3, -12. Very close. That one's way down there, isn't it? Draw my line. Alright, so I did that one because that one's not quite as easy, right? I can't just find a point like we did in our first one and say, I think it's 1-4, and then prove that I'm right. This one is not very evident where the midpoint would be. It's not going to be perfectly on a coordinate point. So let's see. If I do, what happens if I say -2 plus -3? Do I have to do that? What does that mean? Right, the total number of negatives there is -5, or I can say -2 minus 3, because this doesn't change anything, right? So -5 halves. That's my x value. Leave it as that. Leave it as that. We really want to change things sometimes, especially when we see mixed numbers in math. That's an elementary skill. As we get older, we can leave it like that. What was -5 divided by 2? -2.5, right? So that helps us visualize exactly where it would be. If I turn that into a mixed number, that's going to be a little harder for people to visualize. And then -8 minus 12 more? -20 divided by 2? -10. There's my midpoint. There's my midpoint. So it would be in the middle somewhere, -2.5. About right there. Boom. Alright, erasing. Are we good? We're going to use this again in just a second. Pop back over to notes. And I'm going to show you how to make these easy. Okay, this one, reverse thinking. There's a very easy way to do these. A lot of kids want to use the formula to plug in all the things, but let me show you. Always draw a picture in geometry. Always, always, always. If I don't have a picture, I'm going to draw it. Given a point and a midpoint, find the other endpoint. So as soon as I see that, I know I have a point, a midpoint, and another endpoint. A is my first endpoint. M is what they're calling the midpoint. And they want me to find this other endpoint B. They don't know where it's located. So I could go plot and figure this out. I could. Or I could simply say A is at 3, 4. M is at -5, -10. And we're trying to find where B is. So what? Color. To get from 3 to 5, -5, I'm sorry, I'm going down 8, right? So to get to the other endpoint, I need to go the same distance. So -5 to here, I need to go down 8. So -13. My y value, I'm going to do the same thing. To get from 4 to negative 10, what am I doing? Subtracting 14. So that means they went down 14 on the coordinate plane to get to the midpoint. So to get to the other endpoint, I have to travel that exact same distance. So minus 14 more. There we go. There's my other endpoint. No formula needed. Just using common math. See if you can do number 4 and 5, and I'll write the answer up in just a second. I'll put that back up in case you're still looking at it. Sorry. You got it? Caleb, what'd you get for 4? Good job. That's right, for number 4. Anyone got number 5 yet? Okay, hold on one sec. I think you're the only one. Let's give everyone a second. Alright, we got 5? Alright, I got negative 19, and what else, Mia? Good job, that's it. Okay, number 6 will be on your quiz. I'm telling you right now. Yes. Do you have the answer to number 6? Is that what you're telling me? You what? Oh yeah, that's fine. Yeah. Don't give everyone the answer for the quiz question, but yes. She got it. To figure out number 6, you don't have to do it right now. I would study that one for homework. I'm just giving you a heads up. That one will be on your quiz. You did. Okay, guys. We're going to do this last little part, and then I'm going to give you a break before we finish up for the day. Distance formula. The first formula you learned was midpoint. So given any line segment, I can tell you exactly where the middle is using a graph or by the formula, right? Distance formula is very easy to understand if you understand where it comes from. So again, I'm not going to tell you what the formula is until after I show you where it comes from. So you need your boards. We're going to do number 7 on our board. So I'm going to plot 7 quickly. Please meet me there. Negative 4, 3. That is K. Negative 1, negative 2. That's L. And the question in our notes asked me to find the length of this, or the distance from K to L. That means the same thing. So if I see find KL, that means find the length of KL. If I see find the distance from K to L, that's the same thing, okay? So, watch. Here's this slanted line. How in the world could I figure out how long it is? The whole reason the Pythagorean theorem was discovered was to find distance. Can I find it? 3 squared plus 5 squared equals c squared. 9 plus 25 equals c squared. 34 equals c squared. What is the inverse of squaring a number? Square rooting a number. Square root of 34, about 5.83. So then I can pop over here, and I can say KL equals, well, actually I'm going to say about, because it's a decimal, 5.83. Well, that's fun. We're going to do 9 the same way. So erase your triangle. Let's do 9. Number 9. We're skipping 8. We're going to do number 9 together. You'll need to turn it vertically probably. 310. A is at 310. And B is at 9.2. There we go. You think you know what to do? Hey, watch. Stop drawing and watch. Ready? This is 6. This is 8. That means this is 10. 2, 3, 4, 5, 6, 7, 8. It's okay. Well, how did I know that so quickly? I can do the Pythagorean theorem. 6 squared plus 8 squared.
64 plus 36 is 100.
Right. So I end up getting the square root of 100, which is 10. But this is also a very special case called a Pythagorean triple. And a Pythagorean triple is any time we have all whole numbers that satisfy the Pythagorean theorem. 3, 4, 5 is another one. So the minute that I drew this and I saw 6, 8, I just know my Pythagorean triples. I knew it was 10. I didn't even have to do the math. You don't have to have those memorized now, but anytime we get whole numbers, it's a Pythagorean triple. Okay? So I saw 6, 8, and thank God it wasn't 7. Saw 6, 8, and then it was 10. Yes.
When we going to finish the math?
I'm going to make a plan for that. I'm not worried about it right now. All right. Just in case, though, let's write it out. 6 squared plus 8 squared equals c squared. 36 plus 64 equals c squared. We're proving it. This is how we're proving it's true. 100 equals c squared. Then I would square root both sides. I'm going to ask you guys a question right now, and you're going to tell me the wrong answer, and you're going to want to fight me. You're going to be like, this is the right answer. And I'm going to tell you that it's not. What's the square root of 100? No. What's the square root of 100?
67.
No. Square root of 100.
Huh?
Square root?
Uh-huh.
Oh.
100.
Oh, plus or minus 10. But hey,
It's still right.
it's not completely right.
But it almost can't be.
Could distance ever be negative? No, so we know it's the 10 right there. All right. Here's your formula. Your formula is going to make sense now because you know where it comes from. The distance formula is the opposite of the Pythagorean theorem. The last thing that we did right here is we took the square root, right? So this is the square root of x2 minus x1 squared. That's my a squared. That is asking how far did we move on the x. So from x to x, I went 6 units. A squared. Plus y2 minus y1 squared. So square root of a squared plus b squared. That's all it is. I prefer to write it like this, and if you want to do it like this, you can. If this makes sense to you, if you've learned it this way, great. If you haven't, today's your lucky day. I don't want all this. I want to say the change in x squared plus the change in y squared. In math, we use a triangle to represent change. If I'm figuring out the change in something, I'm figuring out how long it is on the coordinate plane. So I like to write it like this. x2s and x1s, sometimes that confuses kids. It just means there's two x values. That's all it means. Doesn't matter which direction I did this in if I use the formula. It does not, because at the end of the day I'm going to square it. So it doesn't matter. So if I were to say on this one, -1 minus -4, which is -1 plus 4, which is, or if I said -4 minus -1, we're going to get the same thing and we're going to square it. Doesn't matter. Okay, we did 9. 8 is yours. 10 is yours. This is your challenge right now, but you also have a little bit of a break. So I'm going to stop this video up here for